That's great. All right, guys, quiet down. Here we go. Got to roll. All right, so this lesson is like an expansion of Friday's lesson. We just have to do a little bit more complicated radical equations. All right, so these are a little bit more complex. And so what do? All right. Really, the first step is the only difference. You have to isolate the most complex radical. The most complex radical. The rest will be similar to what we did. So at that point then, once you get the most complex radical isolated, you're going to raise both sides to the proper exponent. So if they're square roots, we're going to square both sides. If they're cube roots, we're going to cube both sides. If they're fourth roots, we're going to raise both sides to the fourth power, etc., depending on what kind of root it is. All right, after you do that, you are then hopefully able to isolate the variable. That may take some maneuvering. And then you have to be careful to check for any extraneous roots. Check for extraneous roots. All right, so that's the idea. Isolate the most complex radical, raise both sides at proper exponent, try to isolate the variable, or isolate the variable, and then check for any extraneous roots. Okay, let's do a couple examples. All right, so the first one. In this situation, all we have is one radical. This is similar to what we've done before. You don't want to square both sides right now. If you square both sides right now, then the left side is going to be a mess because it's going to be two binomials. You don't want that. So in this one, you definitely have to move the positive 3 to the other side. So you're going to add a negative 3 to both sides, and hopefully you'll agree the other side is now x minus 3. I mean x minus 1. Right, positive 2 and a negative 3 leaves you a negative 1. So I just simply added a negative 3 to both sides. Okay, there's only one radical, so we isolated it on this first example, and we're going to square both sides. But notice on the right-hand side, you're squaring a binomial. Right, in x minus 1. Okay, so the left is easy because squares undo square roots, so the answer on the left, or the simplification on the left, is the radicand, right? 3x minus 2. All right, no Kool-Aid. And then I'm going to write it out because it'll help some of you to see it. Right, on the right, you have two binomials. So again, when you go to distribute, you get an x squared. The middle is going to be a negative 2x, but again, for some of you, I know saying that won't help you. So on the first distribution, you get a negative x. When you now distribute the negative 1, you get another negative x. And then negative 1 times negative 1 is a positive 1. So that's where we're at right now. 3x minus 3 on the left, and x squared minus 2x plus 1 on the right. And now you say, oh, it's quadratic, which means I can either take the square root of both sides, I can factor, setting it equal to 0, or I can use the quadratic equation. That's got to be in your brain, because that's the conclusion you have to come to when you see something quadratic. All right, so this one has a middle term, so we're not going to immediately take the square root of both sides. We're going to set it equal to 0. So I'm going to move the stuff on the left to the right. Let me go higher for you guys. I know you're straining to see that. Okay, so I got to add a So I have the x squared on the right. I have to add a negative 3x to both sides. That gives me a negative 5x on the right. And I got to add a positive 3 to both sides. So that gives me a positive 4. And now I got to see if this thing will factor. Okay, negative middle term, positive end term. I got to use either a negative 4 or negative 1. Oh, that works. Negative 4, negative 1. That'll give me the positive 4 at the end, and it'll give me the negative 5x in the middle, right? And again, technically, we set each of these equal to 0 to finish. That's why the first one is 1, and the second one is 4. And are both of these solutions okay? So you got to look back at the original problem. If you put 1 in for the variable, you get the square root of 0. That's a 0. And you get 3 equals 3. Okay, that worked. If you put in a 4, you get 12 minus 3 is 9. Square root of 9 is 3. 3 and 3 is 6. And the right is 6. That one works. Both work, but you have to check. A lot of times if you look, when you go to take the square root of, when you go to check, if you end up with a negative radicand, you know that's not going to work. It's imaginary. Again, you got to check your answers on these. So that's the first one, quadratic. What fun, it's awesome. Not a big deal, we've done quadratics, we know how to finish. Okay, you look at the second one. This one has 2 radicals with the variable. So we need to isolate the most complex radical. Well, you got the square root of y, and you have the square root of y plus 2. The y plus 2 is more complex than the y. So we're going to isolate the y plus 2. So your first step is to add a negative 3 to both sides, right? So now on the left, you have the square root of y minus 4 equals the square root of y plus 2. We're isolating the more complex radical. We are now ready, right, to square both sides? So be careful, though. It's not the y squared minus the 4 squared, it's the side squared. The y, square root of y minus 4, it's that side squared. So the right's easy, that's y plus 2. But again, on the left, you get 2 binomials. And that's not a difference of 2 squares, right? So, square root of y times square root of y is y. But look, notice what's going to happen on the outers. You get a negative 4 times the square root of y, and look at the inners. You get another negative 4 times the square root of y, for a grand total of negative 8 times the square root of y. That's just the way it is. That's the middles. And then when you finish it out, negative 4 times negative 4 is a positive 16. That's the left-hand side. The right-hand side is still y plus 2. Okay, at this point, you have to try to isolate the variable. Y's on both sides cancel each other out, right? If you added a negative y to both sides, wouldn't that get rid of the y's? It would, whenever you have the same quantity on both sides. Okay, that only leaves us the square root of y to isolate. So we got to move the 16, and we got to move the negative 8. Do you agree with that? So we're going to move the 16 by adding a negative 16 to both sides, right? So that's going to put this at a negative 14, right? Positive 2 and a negative 16 is a negative 14. And then we're going to divide that by negative 8, and that's going to move the negative 8. So here's where we're at. The square root of y equals, let's reduce this thing, 7/4 So how would you finish it? So in this one, we're squaring both sides twice. You got to square both sides. So now we get y equals 49/16. Y equals 49/16. What fun to check this one. You might want to use your calculator. But you got to check because it might be extraneous, especially when you got to square things twice. Squaring things can cause problems with the math. The left is going to be 7/4 minus 1, right? Because the square root of 49/16 is 7/4. So 7/4 minus 4/4, I know the left is 3/4. So here's the question. If you know what you're doing, I don't even have to go any farther. If you guys will look at the screen. When I take the square root of this value, is that number going to be positive or negative, the square root of whatever number that is? It's going to be positive, right? So I'm going to be adding to my 3. So my 3 is going to get bigger, yes or no? Yes. So can 3/4 equal 3 plus something? The answer is no. So this is extraneous, and the answer is the null set. Though the math perfectly gives us a 49/16, the answer is extraneous. And you always have to check when you're doing these types of problems. Again, what I did was 49/16 is a 7/4 minus 1 minus 4/4 left me 3/4 on the left-hand side. The right-hand side has to be 3 plus whatever this is. Therefore, there's no way it could be 3/4, and it's extraneous. Left side doesn't equal the right side. Any questions on that? Again, you can use your calculator, and you can just use decimals and see if the left side equals the right side. And you'll find out as well that the left side does not equal the right side. No questions on that? Okay, let's do a few more. Come on. Okay, so C, again, we have only one radical. So what would you want to do? All right, so what are you going to do? How are you going to do that? Right, move that -2 to the other side, or +2 by adding a -2 to both sides, right? All right, what would you do next? Square both sides, right? All right, so I'm going to finish the problem while you finish the problem. If you don't need to, don't look up. If you need to, look up. All right, see if you can finish it off. So did you end up with x equal 3? And it does check. You end up with the square root of 1 plus 2 equaling 3. Square root of 1 is 1. 1 and 2 is 3. 3 equals 3, and it worked. I tried to show you each step in case you're wondering there. And so you're just taking it one step at a time. Any questions on that one? Elias?
What did you get from the, it's like a negative 2x minus 2, and then you got the second part plus 2, and you cross out the negative 2 and put plus 2.
So right here, I think, is what you're talking about right here.
Yeah.
So I move this negative 2 by adding its opposite to both sides of positive 2. Right? I'm trying to just isolate that variable. I'll move things added first. So first I move the negative 2, then I divided both sides by the other 2 to get rid of that 2. Right? Really should have done that on that step, right? You get x equal 3. Any other questions, anybody else? Okay, so D is similar. Let me just show you where you're going to end up on this. Would you agree you're going to add negative 4 to both sides? You've got to move that 4, right? Because we want that big radical to be isolated. So that ends up being a negative 4. And now we're ready to square both sides. All right, for time's sake, let me show you what happens when you square 3n minus 4. You get 9x squared minus 24x plus 16. Now, you guys all know how to do that. That's not a big deal. You're just squaring two binomials. And, of course, the right is the radicand, right? 10x squared minus 29x plus 2. So you got a 9x squared minus 24x plus 16 equals 10x squared minus 29x plus 2. Okay, so again, we're saying, quadratic. It's always wise to get the squared term positive. So I want to add a negative 9x to both sides. So 9 of those will wipe out 9 of those, and it'll leave me x squared, right, Josh? That's supposed to be an x to begin with. All right, thank you. No Kool-Aid for Josh. Yeah, again, first edition notes. Sorry about that. Either that should have been an x or all the other ones should have been n's, either way. Okay, thank you, Josh. All right, so our variable is on the left, so we got an x squared on the left. Let's add a positive 24 to both sides. So again, we're getting this set equal to 0. When you add a positive 24, that leaves you a negative 5x, right, with the negative 29. And then let's add a negative 16 to both sides, and that leaves us a negative 14. And now we got to finish from here. And so does this thing factor? A negative 14, 2 and 7, right, with a 5 difference. We like that, and the 5 needs to be negative, so it must be negative 7 and positive 2. So now we get x equal negative 2 from the front binomial and x equals 7 from the back binomial. Okay, negative 2. 3 times x is a negative 6. So I'm checking, right? Checking this negative 2. And remember, originally this was a 3x, right? Not a 3n, 3x. 3 times negative 2 is negative 6. Can this side end up being negative any way, shape, or form? No. So I know this one's extraneous already. The negative 2 is extraneous, not going to work. Does the 7 work? The left is going to be a 21. That's plausible. Stick it in there. That one should work. And again, I'd use my calculator. Because you got 10 times 49 minus 29 times 7 plus 2. Take the square root of it. My guess is that's going to end up being an 17. If all's right with the world. And you just use your calculator. Play with the calculator. Punch it in, brothers. And there you'll be. All right, let's get to the back page. Okay, fractional exponents. How are you going to deal with it? What's the situation? You can turn it into a radical if you'd like. But I want to isolate that. So hopefully you agree. Let's add a -4 to both sides. That's going to make the right a 9. Right, that's going to make the right a 9. At this point, how do you proceed? I think for most of you guys, this might look better as a radical, right? Square root, do you agree? Again, you got to know that rule, and that's cubed, and this equals 9. And you would be squaring both sides. Now you're at x minus 3 quantity cubed equals 81. So what would be next? Luke? You got to take the cube root of both sides. An 81 is a 3 cubed. 3 times 3 is 9, times 3 is 27, times 3 is a 3 to the 4th, actually. So the left is x minus 3. And the right is 3 times the cube root of 3. See, everything we do comes back around. This is a 3 squared times a 3, right? 3 to the 4th. I'm sorry, 3 cubed times 3. 3 to the 4th. So what's cube root of 3 to the 3rd? 3, and you're left with 1 3 inside, right? Take the cube root of that, get a 3 out, left with 1 3 inside. All right, and the last thing on this is we're going to add a positive 3 to both sides. And x equals 3 times the cube root of 3 plus 3. Hunter.
Why aren't we able to, when it's square root of x minus 3 cubed, why aren't we able to take the square root of that and get an x minus 3 times the square root of x minus 3?
So you're saying right in the beginning.
So like the first step you did was
Yes.
x minus 3
Mm-hmm.
cubed, and you had to square the whole thing. Why can't we just take the square root of 2 of those and then have one outside, one inside?
I think the answer is you can. And so we took square root, and so we're still at 81.
I don't think you would be at 81 yet. You'd still be at 9.
Well, you got to square both sides, right?
Yeah.
Oh, we didn't square. Yeah, we didn't square both sides yet. Right. I agree. We're at 9. We're just taking the square root. We haven't done anything else yet. All right. So what are you going to do at that point, though? How are you going to continue? Because you got to get to x. So that's true. What you did is true. The math will work. But now, how are you going to get this taken care of? You have to isolate that radical. So you're going to have to move your x minus 3 to the other side. You're going to have to square both sides. And now you're going to have to continue on from there. So, though true, it just leaves you a complexity. All right. I'm going to leave F for time's sake. There is an example like that in the book, and you may have to go there for those decimal radicands or decimal exponents. So you're going to have to look in the book for an example there. I'll finish that tomorrow. I want to get to this type of problem today, though, being I didn't get to it on Friday. Okay, find the change in kinetic energy, delta K, if the initial velocity, V of I, of a snowboarder is 6 meters per second and accelerates to 15 meters per second and has a mass, and his mass is 74.8 kilograms. All right. So find the change in kinetic energy. So hopefully you agree we want to isolate this delta K. Right? So again, if this were physics, we would try to get to that variable first. We're going to solve for the variable. So what would you do right now? Square both sides, right? So v of f is the final velocity, it's squared. And the right is 2 times delta k divided by mass plus v of I squared. Don't let it scare you that there's a bunch of stuff that you don't know. Just do the math that you know. Right, Destiny? Yes, sir. Yeah, sleeping. So, all right. So add a negative vi to both sides. Vi squared, right? Things on the bottom go to the top across the equal sign, right? That's going to move the m. Things on the top go to the bottom across the equal sign. That's going to move the 2. And now we have delta K isolated. Change in kinetic energy. Again, all I did was multiply both sides by m over 2, right? The reciprocal, we've been doing that since day 1 of equations. And again, I needed that parentheses because it's m over 2 times the left side, which is a v of f squared minus v of I squared. Now you're just putting in the values. So mass is 74.8, and you should always include your units, kilograms. Final velocity, so initial velocity of, let's see, 6 meters per second. Accelerates 2. Nope. That was initial. Final velocity 15 meters per second. All right, it's what he accelerates to. Minus the initial velocity, and that's going to be squared. Minus the initial velocity, 6 meters per second. That's squared. And all of this is divided by 2. And now it's just a calculator problem. So you got to take your calculator. You got to be careful because you're doing 15 squared minus 6 squared, and then times 74.8, and then divide it by 2. Okay, I got 7,068.6. All right. 7,068.6. Now, what do you have? You have kilogram, meter squared, per second squared, and that is a joule. Right? You say, how do I know that that's a joule? If you wrote down the problem from yesterday, or the one that from Friday that I put up, a kilogram meter squared per second squared is a joule. Joule is a unit of energy. Okay? All right, be careful. Again, if we have a snow day tomorrow, there will be a video to watch and homework to do. Sorry about that, but I can't lose another day.